Okay, tonight's homework was problems 2, 4, and 7. So let's just gaw this out here real quick. We've got a 15, so this is the problem number 2, a 15 milliliter sample of acetic acid. So if you look up acetic, remember I ate something icky. That's the acetate ion, which is C2H3O2 with a -1 charge. And since it's an acid, it's combined with an H. So that's HC2H3O2. Is titrated with 34.13 milliliters of 0.9940 molar NaOH. So that's Na plus and OH minus. And since this is all 1-to-1, this is going to be HOH plus NaC2H3O2. And it's all +1 and -1, so it's completely balanced. And again, I'm just trying to figure out, it says determine the molarity of the acetic acid. So my answer is going to be question mark big M HC2H3O2. Right? And remember that molarity is for every blank moles of acid, there are 1 liter of acid. And again, remember I emphasized, remember you need to use number, unit, and stuff, which is the one that people keep missing, to keep your for every straight. Okay? So now we say, okay, well, what else do we know about this stuff? Well, I know, I'm going to put this in black. I know that I've got 15 milliliters of this. And I know that I've got 34.13 milliliters of this. And if I were to convert that to liters, I'll just do it real quick. 0.015 liters, 0.03413 liters. And the molarity of the NaOH is 0.9940 molar, which I can write a for every statement for that. For every 0.9940 moles NaOH, there is 1 liter of NaOH. Number, unit, stuff. Okay? All right, so that's all the stuff that was given to me from the problem. Now, I am looking for the number of moles of acid in 1 liter of acid. Do I know how many liters of acid I had? Oh, I do. It's right over here. So that's going to be a part of that forever statement. And what I'm really looking for is the number of moles of this acid. Okay? So that's what I need to solve for here. And I can use the 1-to-1 ratio here to solve for that. So if I know that there's 0.9940 moles of NaOH for 1 liter, well, how much is there for 0.03413 liters? Well, it's going to be about 3% of this number. It's going to be almost the exact same thing since this is a 1, since 0.9940 is almost 1. And so we got almost 0.03413, 0.03393. And that's moles of NaOH. And now because there's a 1-to-1 ratio between these two, I know that this number is also 0.03393 moles of the acid. And now I can utilize that for every statement from above for this one. So I know that for every 0.03393 moles of acid, there are 0.015 liters of acid. And then for every blank moles of acid, there are 1 liter of acid. So I figure out my factor, and I end up with, this would be times 66.66, which means this is times 66.66. 2.262 moles. So this would be 2.26 molar HC2H3O2. Okay? notice that I have number unit stuff for each one of these. Let's go ahead and skip over to question number 4, if I can. Okay, so it says a certain acid and base react in a 1-to-1 ratio. So that just tells me that I've got an acid, I've got a base, and they're going to form HOH and a metal and an anion. And the important part is that this is 1-to-1. And so they say if the acid and base solutions are of equal concentration. Okay, well, if they're of equal concentration, let's just make up a number. If this is 1 molar, then this is 1 molar. And it says what volume of acid will titrate a 20 milliliter sample of base? Well, if this is 20 milliliters and it's a 1-to-1 ratio and they're both the same concentration, that's just 20 milliliters. Okay. Question B said, if the acid is twice as concentrated as the base, okay, so now this one is 2 molar and this one is 1 molar, what volume of acid will be required to titrate 20 milliliters of base? Okay, well, this one's 20 milliliters and it's half the strength of the 2 molar. That means that since this one's going up, this one has to be going down by the same factor. So it requires only 10 milliliters of that. And then part C says, oh, I can't get it all the way up there. Hold on a sec. And then let me just real quick erase this and do part C. Says, how much acid will be required if the base is 4 times as concentrated? Okay, so let me go back. It's HA plus MOH to give me HOH, and it's all 1-to-1, plus MA, and it says, all right, how much acid will be required if the base is 4 times as concentrated? So this is going to be 4 molar. We'll make this 1 molar, and it says we use 20 milliliters of base. Well, if this is 4 times as concentrated, right, that means that I must use 4 times as much of this. So we get 80 milliliters. Okay, so far so good. One last problem, and I picked one here that has is not 1-to-1. So it says an H2SO4 solution of unknown molarity. So I'm looking for the molarity of the acid solution. So let me just put an A. I'm looking for question mark molar H2SO4, which means I'm really looking for the number of moles of H2SO4 in 1 liter of H2SO4. Okay, so all right, so let's write down this, and I'm titrating against this solution, and the titration requires 42.27 milliliters of NaOH to reach the equivalence points with 25 milliliters of the H2SO4. Okay, so let's write out our balanced equation. We've got H2SO4 plus NaOH, and that's going to go to Na2SO4 because this is a +1 and this is a -2, so we need 2 +1s to balance out that -2, plus HOH. I've got a 2 here, and I need a 2 here. Okay, so far so good. We've got 1.209 molar of this, and we said that we got 42.27 milliliters of it, which is 0.04227 liters. And then we've got 25 milliliters of this, which is 0.025 liters. And again, we're looking for the molarity of the acid, which means that I need the number of moles of this acid over here. Okay, well, I do have the number of liters. I've already got that. That's right there. So I've got part of that for every statement, but I don't have the moles yet. All right, so I know that from that for every 1.209 moles of NaOH, there are 1 liter of NaOH. And I didn't use 1 liter. That would make life too easy. For every blank moles of NaOH, there are 0.04227 liters of NaOH. And I just multiply by 0.04227. And we should get about 4% of that number. And that is 0.0511 moles. So if I have 0.0511 moles of this, and it's a 2-to-1 ratio, then really this is half the number of moles. So if I divide that by 2, that's 0.02555. Everybody follow me there? Because this number is 2 to 1, then that means that this number is twice as big as this number. Okay, just basic proportions. I'm just going to erase a little bit of this just to give me that back, just to give me a little bit more space. And so I can say then that for every 0.02555 moles of H2SO4, there are 0.025 liters of H2SO4, and I'm really looking for 1 liter of H2SO4, and so I want the number of moles of H2SO4, which will give me the molarity because this is for 1 liter. 0.025 times 40 will give me 1. So multiply that by 40. Then I get 1.022 molarity. So the answer is going to be 1.022 molar H2SO4. Okay? I hope that helped. Quizzes tomorrow. Have a good one, guys.